Well, good afternoon, everyone, or I'm sorry, good morning. COVID time, it doesn't really have the same meaning anymore, does it? So um, anyway, good morning. Welcome to the November ATI Town Hall. As we've talked about in the past, we've been transitioning. We've finished the strategic planning process. I'll say just a brief remark about that here in a minute. And so we're now moving into this really these town halls being really about showcasing and the research that we're doing, the research that we want to do, the research that we could do, and all of that will come in the form of any discussions that happen in this forum, in this town hall, any follow-on discussions or email chains that happen, as well as the communications, directly from particular researchers to this audience. Through the formal interactions here in the town hall. You would have seen an announcement. I think the first one of these that came out, the invitation, we actually said that we were going to have two speakers today, Alex Hainan and Mizanur Rahman. Turns out Alex got pulled away, so I think he and Bharat and Alan Parrish and some others are up at Redstone Arsenal looking at some autonomous self-driving vehicle military type applications. So we'll excuse them from today's town hall since they're up there doing some business development. So what I want to do today is just some quick updates, kind of show you where we are as in moving towards the implementation part of the strategic plan. Now that we have a plan, it's been formalized, adopted, and put out there, and then. As promised, we will have a speaker. I'll bring Alex in. I've given him a rain check. I'll bring Alex in later on to talk about some of the stuff that he's got going on, some of which you may know about because you guys, many or most of you are on campus or familiar with some of these the action project and some of the things Alex has going on. But I think there's also some interesting things that he's got coming down the pike that bear a presentation in and of themselves. So I'll run through a couple of quick things here, kind of update you, and then I'll turn it over to our guest. I'll introduce and turn it over to guest speaker, and then we'll open it up, any sort of discussions, questions, answers from me to the speaker or each other, because this is a town hall, right? So as I said, the strategic plan has been finalized. It's been put up on the web. It's posted there on the ATI microsite. Seen a snapshot, a screenshot of this before. So this has been up and it's out there, and we're continuing to expand and improve on it. One thing that has happened since we last met is ATI is now officially on Twitter. So all of you who are on Twitter and interested in such things, please please follow and promote and retweet and help us get out there. We don't have President Trump sort of numbers here on Twitter in terms of followers, but 26 is a pretty decent start for something in such its infancy. But you'll see here that the link to the microsite and the strategic plan is actually there embedded in the Twitter profile page. So we're trying to create sort of this feedback loop between the drive people to the website, using the Twitter and all the things that you do with social media. Once we get the Twitter kind of up and running and feel good about it, Rhonda Strickland and I are talking about, we'll spin up a LinkedIn page as well. So there'll be more information about that as we go along. But again, if you're on Twitter or know people that are on Twitter and use it for professional purposes, please link to ATI. So this is some perhaps interesting news and developments coming out from the perspective of implementing the strategic plan. So you remember one of the big things that came out of the strategic plan was this idea of 5 research themes. And so Alan and I had been going back and forth, and we'd had this idea of spinning up some collaboratories. I think they were talked about in one of the previous town halls, and they were sort of more centers in incubation or centers with training wheels or whatever you want to say. We sort of changed the terminology, actually gone back to the sort of the more pure definition of what a collaboratory is. So things that we used to call collaboratories, we're now calling labs. And so that would be the blue circles here. And the red circles are centers, CAPS, what used to be UTCA, which is now CTOPS, the Center for Transportation Operations Planning and Safety, and some of the other centers around campus, CBER and that type. So now this idea of a collaboratory, these are the black circles. And so what we've done is we've created the collaboratories, and there's, I think quite logically, there's now a collaboratory for each theme. And these collaboratories, like the true meaning of the word collaboratory, these are not organizations. There's no director, there's no hierarchy in that way. But what these are essentially ATI's functionality for facilitating research among and within and across intra and inter centers, right? So what I'm in the process of doing, and I'm working with Alan and some others, is the idea is that there will be an ATI appointed facilitator or really more of a coordinator for each collaboratory. And so the purpose there is that person will not with any authority over any of those centers, but will coordinate and facilitate these interactions. Now, how these interactions will ultimately play out, certainly to start with, I'm happy to see how these. I'm happy to give some guidelines and some suggestions, and then see how they pan out. It may be that the Transportation Safety, Security, and Accessibility Collaboratory, maybe they get together and they decide that there's a designee from each center and each lab, and they want to meet every month. That's great. Maybe the Digital Transportation Collaboratory, maybe because of the individuals involved or the type of work they're pursuing, maybe they don't want to meet every month. Maybe they do it on some other more ad hoc basis. So as long as we have the interactions happening and the ATI facilitator coordinator is communicating between ATI and the member centers and across the other collaboratories, communicating opportunities, helping coordinate opportunities, helping support proposal development, helping support the technology transfer, getting reports, papers, presentations communicated out to ATI, out to the website, out to the Twitter, all the things that we need to do. That's how this is going to be a major way that ATI supports the research among the different member centers, and ideally among the collaboratories, because no doubt there will be opportunities that not just cut across all the centers within one collaboratory, but cut across different collaboratories. So what you see here is sort of the initial list. When we reach out and have the first interactions with the individual or with the separate collaboratories, it'll be the designated ATI facilitator coordinator and me to kind of sit down and talk it through. Is there someone we've left off? Is there things that we need to know from the center's perspectives? Because the whole purpose of this is ramping up what I'm calling our collaborative capacity. So when big opportunities come in, we're not starting from scratch. We're not connecting the dots. That ATI is doing what it's supposed to, and it's got people connected. It's got, common interest and disparate interest and all the things that we need to do to manage and be ready to jump after opportunities. And opportunities may be things that come from Pivot, Angie Schott's office. They may be things that come directly from a federal agency. It may be something that Justice, our outreach director, and I like to think of him as our political fixer, comes back from the state legislature and says, hey, we need to get on this. Or it may be things like for the coming year, once we get past the election and everything in January, the United States DOT is going to start looking at the University Transportation Center competition again. And that is the absolute holy grail that ATI will be putting a whole lot of efforts into once we have some guidance from Washington on when that will be formally announced and what directions it will go. And that will be a multiple center. There'll be a lot of moving pieces there. So I want to have this collaborative capacity built up and in place, and ideally the kinks worked out as we move into 2021 and get ready for some of these next big opportunities. Now, what I also should say is while it's not one of the specific research themes, obviously one of the major missions for ATI is the state service component. I made the comment about justice bringing back opportunities or requests back from Montgomery. These might come from the legislature, but they may come from directly from ALDOT or some organization, some other state organization. And so in some cases, there'll be things that start with the state service, but then maybe shift off to one of the research themes, because there's actual academic scholarly research that can be done on top of whatever policy type, advisory research or consulting that could be done for the state agencies. So this is kind of a snapshot. When we get through with the rest of this presentation and after the speaker's done, I'm happy to throw this back up and we can talk about questions. I'm obviously happy for suggestions. One thing that I do want to say that I did leave off, what you see here, the different circles, different colors and type things are existing centers or existing labs within ATI. Now I have a couple of things here in yellow. There's not currently a new connected and autonomous vehicle lab, but I think when you see the speaker's presentation today that there's a potential for a new one focusing on the cybersecurity aspects of connected and autonomous vehicles. And I know that in mechanical engineering, there's a new lab, a new center that's working its way through the proposal process through the college, and then will ultimately go to the Board of Trustees. And while it's not in and of itself a solely transportation focused center, it does have some components and some technical contributions to make to at least these two collaboratories. So we're already kind of thinking forward about how these will interact. But in addition to the circles that you see here, regardless of the color, we also have and are finalizing kind of a sign-up sheet and survey to have individual affiliates and eventually a fellows program for ATI. So excuse me. So as part of the centers or as just individuals who are interested in transportation from anywhere across campus, but not necessarily affiliated with one of the centers or labs listed here, they will also engage in these collaboratories within the structure here, and at least that's the plan and the idea going forward. Again, happy to talk about this and take some questions in general, but I wanted to give you a little idea of kind of how this is going and perhaps more importantly where this could go. So let's take the sustainable transportation infrastructure one. So this is a lab that's being spun up, or I guess it's up and running now, that's being run by Laura Myers on emergency communications and community resilience. CBER and some of the others that you see here, the Insurance Institute that are interested in infrastructure. Obviously, the Center for Sustainable Infrastructure would be a major player here. So the idea is that ATI, through the facilitator, helps bring centers and individuals together around this research theme, and we go after projects that speak to this theme. So just recently, we had an opportunity come through from the National Oceanic and Atmospheric Administration on sea level rise and how it would could potentially impact surface transportation resiliency. So before all of this was completely formalized, but a process that's informing how we're doing this, we got folks together, had a big Zoom meeting and some follow-up discussions, and we responded to this. And so we put in a letter of intent to NOAA for this. And you can see there's actually the Water Center and Water Institute, Center for Sustainable Infrastructure. We reached over to biology. We reached over to geography. So this is the kind of thing that we want the collaboratories to be facilitating and producing, these multiple interdisciplinary, multiple center type projects. So we put this in. I'm a little disappointed to report that NOAA didn't give us an enthusiastic thumbs up on this proposal, but I think there was a lot of interesting interactions that happened in the development of this. I see maybe a group forming that may approach the Port Authority of Mobile and start looking at this type of problem and looking for other funding sources to look into this sort of thing, which again is exactly what we want these collaboratories to do. ATI bringing opportunities, bringing some coordination and leadership, and eventually turning these opportunities into funded projects, into published papers, and all the things that go with that. So here's the digital transportation one, right? So this is one that's really focused on data, machine learning, all different things. Here's a solicitation that just recently dropped from the National Science Foundation, and you can see one of the partner organizations right here is USDOT. So this information has been communicated out. There are some folks already having some conversations and talking about this. And in particular, there's a theme one of this competition: human and AI, artificial intelligence interaction and collaboration. And I don't expect everybody to read this right now, but what I will let you know is one of the things that they're specifically interested in, and that's why USDOT was a partner, is transportation. So the collaboratory and ATI, we're already trying to work this out and figure out how these things work together, and we're identifying opportunities and going after them. Here's one: the transportation safety, security, and accessibility. And so when you really get down to the idea of accessibility, accessible transportation is a huge topic. It's everything from, transportation issues specific to women. The Transportation Research Board has an entire committee. There's an entire TRB committee that focuses on women's issues in transportation. So there's all sorts of things. Obviously, COVID has affected transportation accessibility, particularly with respect to public transportation. As part of this, we've identified a Federal Transit Administration opportunity to help small urban areas and rural public transit agencies in small urban areas and rural areas do a better job of dealing with COVID. So this is actually now turned into a proposal that we worked with ALDOT, and we actually worked with University of Alabama, Huntsville. And we now have a proposal that's gone into this. I can't remember how much it was, maybe $500,000 over 2 or 3 years. But a really interesting proposal to help these small transit agencies in the Wiregrass, down around Dothan and Enterprise, all over rural Alabama, that are essential for people getting to health care and elderly trips and things, to help them do a better job of managing the COVID-19 situation with regard to their operations. And very interestingly, one of the things that this call wanted us to do was to help, you see here, increase the confidence in public transportation. So part of what this project will do is actually some outreach and some different things to help people know that, look, this is being taken care of, and you can now get to where you need to using these public transportation services in Alabama, because we are on top of the COVID situation. Now, interestingly, this is another example of a project, accessibility and how COVID affects transportation accessibility for those people who depend on public transportation. But also, it does another thing that ATI is really in the business of doing, and that's support young faculty members. And you all will remember from the last ATI town hall, you heard from one of our new hires, Jinwoo Qian, who had done his dissertation work on the propagation of infectious diseases within public transportation systems. So Jinwoo is actually the one who led this proposal for us and coordinated with ALDOT and UAH. So again, supporting young faculty. This happens to be civil engineering, but supporting young faculty across campus is a major mission. And I think this structure of doing it within the themes and building collaborative capacity around these themes is our ticket moving forward. Now, last one here, the theme of connected and autonomous vehicles and infrastructure. We are right now in the process of considering another National Science Foundation proposal opportunity. Again, you see here, United States Department of Transportation, Federal Highway Administration, they're interested in this because there is a huge issue, a huge amount of opportunity for looking into the cyber security and cyber physical systems associated with connected and autonomous vehicles. That also happens, or while that falls very nicely and very squarely within this ATI Research Collaboratory, it also falls very nicely under the idea of supporting this new faculty member, Ms. Mizanur Rahman, who came to us from, finished his PhD up at Clemson University, and then stayed on there as a postdoc, where he was the associate director for their University Transportation Center, UTC, USDOT funded center on connected mobility. And this is a nice way to segue from the ATI research themes, supporting young faculty members, to our entertainment for the day, which is Dr. Rahman. So I'll stop this screen share and turn it over to Mizan and let him introduce himself to you and give you a little bit of background on what he's been doing and what he plans to do here. All right, Mizan, it's all yours.
Yeah. Let me share the screen. Can you see my screen, Steven?
Yes, sir.
Thank you. Okay, thank you, Steven, for introducing me. So this is Mizanur Rahman. You can call me Mizan shortly. That is easy to go. So in today's talk, I'll talk about transportation cyber physical system for connected and automated vehicles. So before joining here, as Stephen said, I was an assistant director for the Center for Connected Multimodal Mobility. That is a university transportation center funded by USDOT. And I did my master's and PhD at Clemson University, and I did my postdoc too. And I was very much involved in one of the NSF Engineering Research Center planning grant that is about security and resiliency of transportation, connected transportation systems. So before talking, okay, I'm trying to, okay. So before going in deep to the cyber physical system, let's look at it like how we can define it and how the CPS system, because CPS system is there for a long time, cyber physical system, but how we can fit the CPS system in the future smart mobility or future connected transportation systems. So by the name cyber physical systems, we can divide into two parts, like cyberspace and physical space. Physical space, you can consider like vehicles, connected vehicles, autonomous vehicles, and cyberspace you can consider that can process data, make the decision, and send back to the physical space. So currently, I mean, we have this part already there to some extent. We're collecting video data using through our cameras, and we are putting sensors on the roadways, and through that sensors we can sense information. And after processing those information, we can say, I mean, we can make some decision and tell the cyberspace or physical space, like this is what you need to do for reduced congestion. So that is the overall concept. But when you think about the smart mobility system, then we really need to think about the actuation information. So what I mean, you are getting data by sensing from physical space, then you need to process it and generate actuation information. And you need to control the physical space. So there is a control part. So how you are going to control, especially in the era of autonomous vehicles and connected vehicles, that should be very, very useful to reduce congestion and improving safety by sending actuation information. So if you think about that space, I'll talk a little bit more in the future slides, coming slides. But around that space, cyberspace and physical space, there are many research topics. I mean, several research topics, I should say. And the first one should be the computation, how we are designing our computational or computation infrastructure. So for example, right now, we call it roadside infrastructure. You can collect data, sense data, and process it. But how you're going to optimize the computational resources, or how you're going to scale up the computational resources, that is a big question. And then the control, like, yes, you sense information, you're sending to the physical space, but how you're developing the control algorithm for autonomous vehicles, that is a big question, depending or considering different factors, environment, considering environment of autonomous vehicles. And also, it is very important vehicles are moving, so we cannot connect with the wired connectivity. So it should be wireless, but how we can make the communication reliable, or there must be some loss of data because of interference and all other things. So, and also how we can maximum use of bandwidth, because if you have so many sensors in a connected transportation system, that is a big issue too. And on top of it, what you're sensing through communication, all the data, you can develop predictive analytics and make better decision for improving transportation system. So yes, I mean, in a connected transportation system, it looks very good. We have all those things, we can improve the mobility, but new challenges will be there. There will be security issues, privacy issues, because you are getting personal information. And it's a computer, end of the day, when you say connected vehicles, autonomous vehicles, especially autonomous vehicles, it's just like a computer on the wheel, nothing else. So it's a computer. So how you are going to secure it? And for sure, end of the day, human is going to use that system. So nowadays people call it cyber physical social systems. So it should have social component, so that people will be more interested to use it. People can trust it and rely it. So all my research covers to some extent and touch to all those research interest: competition, privacy, control, human factors, communication, security, and data analytics. So these are the high, I mean, these two are very high level benefits, because you are monitoring the system and giving the feedback. So it will make the system safer, efficient, and reliable, more reliable. So that is the goal. So this slide is showing an overall example, like what digital infrastructure we need. This is a simple example, but it can be extended depending on the requirement. And the concept is based on edge-centric transportation cyber physical system. So edge means like you should have the computing resources or data infrastructure close to the data. Otherwise, it will not be effective for transportation system. The reason is safety issues. You need to sense the data, process the data very, very quickly, probably less than 100 milliseconds. So if you do it in cloud infrastructure, that will not be possible to serve the purpose of the application, transportation application. So to build a transportation cyber physical system, we can divide in a general way: mobile edge, fixed edge, system edge. Mobile edge it means the vehicle itself. Fixed edge, it could be roadside data infrastructure, it could be roadside, I mean, traffic control infrastructure, traffic signal control infrastructure. And system edge could be transportation centers, what people are doing in traffic management center. And cloud infrastructure could be a part of the system edge if you don't want to put all your computing resources in the transportation center. So this is overall, this is the high level idea, and for sure you can add another edge depending on your need. So the challenge in transportation system, basically, we have moving components and we have dynamic components. So how we can sense information from all those and serve our purpose. So this is more detail, little bit more detail, like what I showed in the previous slide. If you look at each layer 1, layer 2, layer 3, I mean, mobile edge, fixed edge, and system edge, then you can increase the number of fixed edge. And mobile edge, it could be thousands of vehicles. System edge, you can increase, and you can add another regional edge if you want. But the challenge will be how we are going to stream those data in real time. So the data delivery system, how you can design it. We can have different type of communication option, dedicated short-range communication, LTE, cellular, and 5G is there almost, and 6G probably will come soon. So, I mean, we cannot rely only one communication services, for example, DSRC. The reason is it has limited coverage capability. And on the other hand, if you look at the cellular technologies, it has bigger coverage capabilities, but it cannot serve the purpose for real-time application, especially safety application. So we cannot just rely on one option. Even if you think of 5G, it says like it can combine DSRC, it can combine LTE and cellular. But end of the day, you'll not have available all 5G technologies everywhere. It is not possible. It is quite impossible, at least in near future for sure. So in future, the heterogeneous wireless communication, if you look at the middle box, the orange one, heterogeneous wireless communication concept, like all the communication option will work together, but you need to design that resource controller. So how from one communication option to another communication option, you can switch. So, and depending on the application requirement, which communication option we are going to use it. So that is one thing, and the computational capability, for example, in vehicle application, how you're going to run it, especially in the age where you have limited computational capability. And the message broker, how we are going to design the data delivery system. I'll talk about that a little bit more. And I cited one paper at the bottom, so if you want to look at a little bit more and what it means and what are the definitions, what is the architecture, you can look at the paper. In this presentation, I'll try to give at high-level concept and why I did all those research. But for sure, you can get the detail from the cited paper. So you all know, I mean, we can sense data from traffic signals, transportation centers. Beside that, for autonomous vehicles, there are so many data. I mean, it is proven already. I mean, how much data we can generate every day from an autonomous vehicle. Sonar, radar, lidar, all those sensors per second, you can see how much data it can produce. So per day, I mean, in a month, how much it will be produced. And beside that, there are some other external data sources, for example, news and social media, weather services. To some extent, we use nowadays. When I was at Clemson University, actually we did a research in a group, how we can use Twitter data and predict incident. And it is possible, I mean, by 95%, more than 95% accuracy to detect an accident or incident using Twitter data. So, and probably in future we'll have more data sources and personal handheld devices, cell phone or iPad, this kind of devices. It is producing every second so many data. So yeah, I mean, we need to think how we can develop a data infrastructure, transportation data infrastructure that can be used for improving transportation operation or safety. So this is one of my research I did when I was at Clemson University. We developed a distributed data delivery system. The concept is like, instead of sending all the data to one location, for example, either center or vehicles, we'll have a middleman, we'll have a broker. So we'll send all those data to the message broker, and message broker will tag each data point by name, and every consumer who will consume the data, it could be a transportation application, they can consume the data just by requesting those data by topic name. So we developed a simulation environment, and that environment we showed, yes, it is possible. It could be a distributed data delivery system, and it helps to don't replicate the same data for each one. For example, transport traffic management center, they can just request what data they need. They don't need to store all those data what are coming from different sources. So that is the efficacy and the contribution of that study. And this study, actually, I developed a driver behavior modeling. So vehicle will have sensors, and for autonomous vehicle especially, and it can detect the surrounding environment. But we all know we are adding connectivity so that it can see beyond the sensor range. If there is no line of sight, still it can see it, what is happening. And because of an object, probably you cannot see a pedestrian, but if you have a communication between vehicle and pedestrian, you can detect that, or you can at least know there is a pedestrian. We need to accelerate or speed up accordingly. So these the context of these research basically to develop a model that can fuse the sensor data and data from communication and do the acceleration and speed up accordingly. It's a longitudinal control model. So in the software part, you see the perception part, planning part, and the control side. So when you have the data from perception and planning module, it's actually you need to uh, create the control data, and that data will go to the actuators, and it will controlled by those data points or accordingly. So this is the concept. You can see the detail, as I said before. At the bottom, we have a citation, and you can see and look at the paper in detail. So in recently, there is last 10 years, the pedestrian fatalities increased by 53%. And if you look at the left side, only 2% is reported, 2% increment for all other traffic deaths. I mean, if you think about the increment. So it is very, sensitive topic. Recently, people are trying to address through connectivity. And it is well known, if you have a connectivity between the pedestrians and the vehicles, it can generate pre-crash warning. So you can avoid any potential accident or incident. But the problem is how we can make sure a pedestrian will carry a handheld device, and he or she is going to turn on the application, pedestrian application or pedestrian related application all the time. So it is a little bit unexpected, or we cannot expect that much. So what we did, if we know there are some critical intersections or work zone area, we can use just low cost camera, and using that camera, we can generate personal safety messages from that camera. It is not all about detection. Yeah, detection is one part, but the contribution is how we can generate safety messages, the location, the speed, so that you can let other vehicles know, okay, there is a pedestrian, be careful. So if there is a safety critical location, we can deploy this technology, and we can avoid potential crashes. So this research is more related to communication. How we can maximization or utilization, bandwidth utilization. Uh, as I explained in the previous slide, basically what we're trying to do, we are transmitting data from camera to the data infrastructure, and data infrastructure can process those data. And what it can do, it can produce the safety message. The problem is when you transmit that data, you need a bandwidth, communication bandwidth, but you might have thousands of sensors or hundreds of sensors around that beside the camera. So if you compress the data, compress the video images, videos or images, you can save the bandwidth. So again, there is another question. When you use machine learning or artificial intelligence model to detect object, can you detect it? Because your images could be blurry, and probably it cannot detect, or the accuracy will not be that much. So what we did in this research, depending on the environment, it could be rainy weather, sunny weather, it could be dark weather. So how, at what much we can compress the data and make sure our accuracy level will be that much high. Let's say we can fix a bar 97% accuracy or 99% accuracy. So how can ensure that? So this research is about that. And you can see on the right top corner, it's the live streaming, what we can get from the camera. But at the bottom left corner, you can see the compressed image, and it can detect if it is crossing the vehicle's path. So you can see that in this video. So this research is more related to security. GPS is very important for autonomous vehicles because it can guide from an origin to a destination. But that GPS signals can be compromised by any attacker, or It could be some natural event. For example, big or tall buildings can interfere with the signal. Or if you go through a tunnel, it can interfere with the signal. So if that is the case, how can detect that and signal interference and guide the vehicle towards the destination? So any kind of signal, if you use, I mean, that can be compromised. So what I am trying to do in our new research, uh, mm, using just in-vehicle sensor and the GIS, geographical information system, I can combine those two things and guide the vehicle and detect any kind of GPS signal attack or any kind of interference. It could be intentional, it could be unintentional. So how I can detect that and guide the vehicle. We're not saying it is an independent system, but it can be a hybrid system that can support our existing GPS system. That's the overall concept. And this is the last research I'm going to talk about a little bit. It's cloud, how we can use cloud infrastructure for developing transportation cyber physical system. I mean, yes, state DOT can have computational resources, sense the data and process it, but they need persons to do it and they need computational infrastructure. But if you use cloud infrastructure, so it can be scalable depending on the demand. So that is very interesting fact. And on-demand service, pay as you go. So you don't need to have the resources all the time. Whenever you need, you can do that. So recently we did a research and we found that mobility application, not safety application, mobility application can be run in the cloud infrastructure, and all we can sense the data from the vehicles and process it in real time. And for sure, non-real-time application can be run there too. So far I talked about different type of research, and it covers, these are my research interest. I do research under transportation cyber physical system. So under that umbrella, it has different directions. So I showed some example, yeah, I mean, I love to communicate whoever is interested in any topic, what I mentioned today. So thank you so much. And if you have any question, you can put it in chat box or you can just directly ask me questions. Thank you.
Yeah, please, if anyone has any questions for Mizan on his research, please feel free. I'll go ahead and say, Mizan, because I think you were busy giving a presentation and you couldn't monitor the chat box, but it turns out that Dr. Liu actually reviewed your paper and he had some nice things to say about it. And apparently it perhaps won an award at TRB. Is that correct?
Yeah.
All right. Well, as chair of the search committee that hired you, I'll take a little bit of pride in bringing you here to Alabama on that one. So any questions for Mizan? All right, you can go ahead and undo your screen share. And any questions or comments in general? I presented some general kind of, as we march along in the implementation of the strategic plan. I'll be the first to say, I think I'm just kind of looking at the names and faces here on the screen. I think I know most all of you have interacted, and you guys know me, certainly the people that I've worked with. This is an iterative process, and the most important thing is I really do not want this to be a top-down thing. I mean, the whole purpose of ATI is to facilitate the research centers and make the research centers do what they do better and provide sort of an overarching coordinating structure and framework to create this, sort of more as an enterprise. So I hope that we're on the path to do that. I mean, I always feedback is welcome. Constructive criticism is always more welcome, but I don't bruise easily if you need to be nasty. So we're going to roll this out. Some of you on the screen will be directly involved. Others will be indirectly involved. Some of you may not be as involved yet as you want to be. You know where to find me. Please let me know. And let's see. I see Polonsky. Yes, sir.
Thank you, Dr. Jones. Looking back on your molecule charts, you don't see the PRC on a lot of those, but maybe we should get an asterisk at the bottom because all of these issues have policy implications. They may directly require a benefit from research into statute or administrative rule or regulatory structure. And we stand ready to assist anybody with those efforts.
Oh, absolutely, Stephen. And you're totally right. And that's, that's one of the things that, trying to communicate. I mean, this is, it was a balance between, putting the things there, and this was me connecting. And I think you and I had talked about in a previous one. The policy center does explicitly show up in the EV and fuel economy. And I think we had talked about, I mean, right now, obviously there's a lot of technological advancement that's happening, but I think one of the biggest barriers, certainly in the state of Alabama, are the policy related issues and how, so absolutely. And there's no, those are not exclusive, club memberships, right? This is just an initial structure. And in some ways, CTOPS, the former UTCA, it cuts across all of them. They all do. And, this ideally will be a framework and a structure that facilitates these interactions. And be careful what you wish for, Stephen, because that asterisk may show up in a lot of places. So, any other questions? Any comments? Humorous anecdotes? Electoral college updates, anything? Yeah, because if there's not, I got to get off of this Zoom call and turn my television on and see what's happening in the world. So going once, going twice. Ahmad, yes.
No, I was just saying goodbye.
Oh, okay. sorry to put you on the spot for saying.
No, that's fine. That's fine. That's fine. You have a good afternoon.
Yeah, everybody have a good afternoon. This thing will be recorded. You know where to find me if you need me. And it'd be interesting to see, feedback as we roll this stuff out. And looking forward to having everybody involved. Take care.